Good day everyone, we are the group 2 and we will be reporting experiment number 5, construction of ternary phase diagram with my group members Lanuza, Malabarbas, Obeda, Rios, Uy, Tampico, and Vergara.
The objectives is to determine the efforts of alcohol on solubility of camphor by constructing a ternary phase diagram, and to observe and record the phase changes that occurs as varying amounts of alcohol are added to camphor and water mixture, and to graphically represent the collected solubility data by constructing a ternary phase diagram and illustrating the regions of miscibility and immiscibility for the camphor, alcohol, and water system. The So these are the results for the activity na gihimo namo, and then for camphor and alcohol, parehas lang sila og answers na nakuha. While sa water is first niya na 37.5%, and then 24.53%, 20%, 24.53%, 9.91%, and 21.57%. To get this computation, so these are the results. Gi-compute na mo siya um, using the formula sa camphor, which is percent sa camphor is equal to weight of the camphor divided by weight of total system, and then i-times siya sa 100. While ang sa alcohol is percent of alcohol is equal to weight of alcohol divided by the weight of the total system times 100. Gi-compute na mo siya using while ang sa water kay percent of water is equal to weight of water, and then i-divide sa weight of the total system and i-times sa 100.
So this here is our schematic diagram. As you can see, we measured 1 gram of camphor to 6 gram of camphor. So on with our alcohol. As you can see, ang 1 gram of alcohol is the same amount of the camphor, which is 1 gram. Dapat sila magka-same ng measurement. After that, we pair them together and we mix. After mixing them together, we are to titrate them, and then we observe for turbidity or cloudiness.
So for our guide question number 1, what is ternary phase diagram? What is its importance in preparing mixtures? A ternary phase diagram is a triangular graph that represents the phase behavior and composition of mixtures containing 3 components. Each corner of the triangle corresponds to a pure component, and any point within the triangle shows the proportion of the 3 substances. It is important in preparing mixtures because it helps predict the stability, miscibility, and phase separation of the components under specific conditions, allowing scientists and engineers to determine the correct ratios for desired properties and to avoid unwanted phases in fields like material science, metallurgy, and chemical engineering. This is our ternary phase diagram with our components water, alcohol, and camphor, with our plotted 6 systems showing our binodal curve, and the single phase, which is the miscible region, and the multiple phase inside the binodal curve, which is the immiscible region.
For the guide question number 2, how to do the plotting of ternary phase diagram. For a ternary phase diagram, it is a triangular graph showing the relationship among 3 corners, which is alcohol, camphor, and water, where each corner represents 100% of one component and any point inside shows their mixture. For manual plotting, draw a equilateral triangle, label the corners, and mark each composition based on its percentage. This diagram helps visualize how component ratios affect different phases in a system.
So for the guide question number 3, what is binodal curve or binodal? What does it imply in the diagram? A binodal curve, also called a coexistence curve, is a line on a phase diagram that separates a single phase region from a two-phase region in a multi-component system. It defines the conditions of temperature and composition at which two distinct liquid phases can exist in equilibrium with each other. So in the diagram, the binodal curve indicates the compositions where phase separation occurs, and any point within the two-phase region connected by a tie line to the binodal curve represents a mixture that will separate into two immiscible phases.
So for our guide question number 4, based on your constructed diagram, will a mixture containing 70% alcohol, 20% of water, and 10% camphor remain clear or form two phases? So based on our constructed ternary phase diagram, a mixture containing 70% alcohol, 20% water, and 10% camphor falls outside the binodal curve or in the single phase region. So therefore, the mixture will remain clear or miscible and will not form two phases.
In conclusion, the alcohol acts as an effective intermediary at causal depth, successfully bridging the gap between camphor and water to create a stable single solution by systematically adding alcohol and recording the exact composition needed to eliminate turbidity, like the 39.22% weight by weight camphor and alcohol combination in trial 6. The experiment successfully quantified the exact boundaries of the miscible region. Therefore, the data proves that alcohol significantly enhances camphor solubility, and the final ternary phase diagram will visually confirm this by showing a large, clear single phase area defined by these collective points.